Hello, how are you? I welcome you today to our tutorial, which will go through physics concepts on the topics that we've learned in class, such as densities for grade 10 and length for Form 1. So please, as you prepare for your tests, add this video to your study list. It will help you to remember all the concepts that we've done in class. I'm Sir Fredrick.Jr. and this is the tutorial video. Okay, so we begin with the density of irregular object. So what is the key things are you supposed to remember here? You must know how to find the volume of irregular substance such as a stone, okay, and we learned how to find the volume of these irregular object. Okay, then the mass will be given to you, or it will be measured on the electronic balance or any other instrument that we use to measure mass. Then you use that mass in your calculations. So we have a question: calculate the density of the stones showing on the diagram. So we have a stone pressed on the electronic balance and it is reading as 600 grams. Okay, so what is missing of this object is the volume. So we'll get a measuring cylinder as the second step. Pour water in it like we are having on the diagram. When you pour water in it, you measure the volume of this water. So this will be volume 1. So volume 1 of this water is just 5 centimeter cubic. Then you get the stone and tie it to the string, a thin string. That's a caution, because if you use a large string, it will increase the displacement of water, so it will distort the experiment. So you tie it and gently you lower it in the cylinder. So you observe that water will rise going up. So that water together with the stone, you record it as what? As volume 2. And according to what we've been given in the diagram, we are having 10 centimeter cubic. So the volume of the stone will be solved by the final volume, which is volume 2, minus volume 1, which is also called initial volume. And what does that give us? It just gives us volume of a stone is equal to 10 minus 5, and this is just 5 centimeter cubic. So this is the volume of a stone. Then what do? You go ahead and solve what? Density, using the formula. So if you want, you can just write your formula like this: mass over volume. So volume you've solved, mass has been given to you. So data, I always encourage you to correct data. Mass is 600 grams and volume calculated is just 5 centimeter cubic. So you go ahead and replace it. So 600 divided by 5, and what is that? It just gives you 120 grams per centimeter cubic. We are done with the first one. Okay, then let's try a part B and see how we can solve that. So other method of determining the mass of an object, it's not always on the electronic balance, because we have different instruments that we use to measure mass. So we have also a beam balance, where a known mass is pressed on the other side and an unknown mass is pressed on the other side. So we have a stone on the other side and the known mass is 400. So this also means that this stone has a mass of what? Has a mass of 400 as well. So the data for this one, so mass of a stone is as well as 400 grams. Okay, so we are looking now for volume. We don't know the volume. So we have other method of finding volume apart from using a measuring cylinder. You fill water there, then you rinse your stone. So we have the other method by use of what we call overflow can. Overflow can. This one is also called Eureka can. So what do? You get a Eureka can, you fill it with water until it reaches on the sprout here. Okay, so what you do now, you get a stone tied to a thin string, you rinse it into the overflow can. So what happens is that water will rise. So when it rises, it will start dropping here. Start dropping in the measuring cylinder placed just under the sprout. So you wait for it to stop dripping and you pick the volume of this water. So the volume of this water is equal to the volume of this stone inside here. So the volume of the stone is the water displaced in the what? In the cylinder. And so on our data, the volume of the stone is just 15 centimeter cubic. Okay, 15 centimeter cubic. Then we can go ahead and solve what? For density. So density is just mass over volume. Okay, so I'll put 400 there, given grams over 15 centimeter cubic. So what do I have? So go ahead and solve. So this will just give the density of 26.7 grams per centimeter cubic. Okay, so and this is how we solve the density of what? The density of irregular object. First, we can go ahead and try this. Okay, so we have this question, a very nice question that is testing all the concept that we've learned today. So the question reads, 100 centimeter cubic of water is poured into the cylinder. A block of copper of 75 grams was gently lowered in the measuring cylinder, and the water level rises to 183 centimeter cubic. Questions: compute the A, volume of the copper block, B, density of the copper in grams per centimeter cubic, and kilogram per meter cubic. Go ahead and solve this. Then when you're done, you compare with my answer. Okay, so let's solve this one now. I hope you've done your part. So solution now. So I'll collect the data given. This is the best practice for any student learning science. You should have the skill of analyzing the question. So volume 1 given to me, I feel it's 100 centimeter cubic. Then when the copper block was lowered into the measuring cylinder, it raises to 183 centimeter cubic. That's my volume 2. So then volume of the copper, I really do not know, so I need to solve that. So, and that's the question for A. So mass given is 75 grams. Okay, so we go ahead and solve that. So volume of the copper is V2 minus V1. So volume of copper is, so V2 is 183, okay, minus 100. So what do we get here? So the volume of the copper, it is just 83 centimeter cubic. Done. We are done with A. Then B, density of the copper. Density of the copper. Okay, so we know the formula of density is just mass over volume. If you also want, you can also solve density using this formula under this scenario. So density is equal to mass over V2 minus V1. This will still take you to the same answer. Okay, so I'll do that. I'll show two formulas here. So mass is just 75 over 75 grams over 83 centimeter cubic. So we go ahead and solve that on our calculators. This just give me the density of 0.99 grams per centimeter cubic. Okay, even if I use also this one, I'll still have the same answer. So density is equal to mass, which is 75 over, so V2 is just 183 minus V1, which is 100. Okay, so density, this will be just 75 over if 183 minus 100, just 83, and this will just take us back to 0.9 grams per centimeter cubic. All right, now if you look at the question, it says in grams and in kilogram. Okay, so we've done the first part of our answer. We've done density in grams per centimeter cubic. Then we need to do it in what? In kilogram. So we'll solve it right here. So in kilograms, in kilogram per meter cubic. So we'll go ahead and we are going to fetch that simple method of converting these things. So if I get it, okay, I'll copy this. I'll copy that so that I remind you of that. So, all right, so we'll bring it right here. We'll bring it right here. Okay, put it there. Okay, so instead of wasting time, we'll just get 0.9 times, we are taking it to what? We are taking it to kilogram times 1000. Okay, so what's that? My answer, the density in kilogram is just 903. Okay, just 900 kilogram per meter cubic. We are done. So we've shown two sides. All right, so now we've looked at density of irregular objects. So let's go ahead and solve the third question. We want to try it out together. Please, if you try, if you want to try, you can go ahead, you pause the video and solve that. So the question reads, the diagram below shows a cuboid. We know the cuboid, that a cuboid is anything that has got a shape like that of a rectangle. Okay, container has 6 centimeter square base and contains water to the height of 8 centimeters. So this is what we are seeing. We have a visual there trying to paint what is in the question. So the first question says, what is the volume of water? All right, we know that the formula for volume of a rectangle or a cuboid is L times B times height. Okay, So volume is equal to length. So we're gonna pick 6 times height of 8. So what do we get? It just give us 288 centimeter cubic. So this is the volume of water. All right, so question B, go ahead and say a stone is immersed into water in the cuboid, causing it to rise to the height of 10 centimeter. Determine the volume of the stone. So what we are going to do is that we are going to solve the volume of this height. So volume is equal to L times B times height. So this time around it will be 6 times 6 times 10, because the height now became what? The height became 10 centimeters. Okay, so what are we getting there then? Okay, so this just give us a volume of 360 centimeter cubic. Okay, now wait, this was the volume when this was the rise in the volume. So now what will be the volume of the stone? So this volume which you solved here, this will be marked as volume 2. Remember the concept under the measuring cylinder, when you pour your stone there, you rinse your stone there, the water rises. But in this case, this volume which we've calculated will be our volume 2, and the volume of water which we solved at first will be our volume 1. So 288 centimeter cubic. So hence the volume of the stone now will be volume 2 minus volume 1. Okay, so volume of the stone is just 360 minus 288. Okay, so what do we get? Okay, then the volume of the stone is just 72 centimeter cubic. We are done. So this is how you solve. So make sure you show your work when you are solving these problems. Okay, make sure you show your work when you are solving this problem. Remember, these marks allocated to this can't just be given after you put a correct answer. You always solve and give what? Give the correct answer after showing your work. So now this makes us to move on to part C. So if the mass of the stone is 100 kilogram, calculate the density of the stone. Okay, all right, as usual, density is equal to mass over volume. Okay, so let's correct the data given. So mass is just 100 kg, then volume of the stone is just 72 centimeter cubic. Now we are having different SI units. At no point centimeter cubic will move with kilogram. One have to follow the other. So which one is easy for you? If you want, let's make this mass into grams. So we know that this mass will convert it into grams by multiplying it with what? With 1000. And this just give us that. Okay, grams. So this is the mass in grams. So I'll use this one to solve for density. So density is that over 72. Okay, so when we plug in on our calculators, this is going to be, density will be 1388 Okay, 0.9 grams per centimeter cubic. Oop, yes, per centimeter cubic. That's correct. Then if you want now to take it into kilogram per kilogram per meter cubic, we can use that method. When we are moving from grams to centimeter cubic, we always multiply by 1,000. Okay, so let's convert that one in kilograms. So we'll get it. So we multiply it with what? With 1,000. So, and this just give us in kg per meter cubic, it will be 388. Okay, 8. So many 80s. At least I should have 680. Okay, comma. Okay, 0.9 kg per meter cubic. Okay, so this is the same density in kilogram per meter cubic. So this is how you'll be solving these problems. I hope it has helped you.